Good morning to everyone present here. Myself Divya, I'm working as an assistant professor in Shriram Engineering College, Tirupur. Now we are going to discuss about a topic on high voltage engineering. Let's go on to the video. I'm going to detailedly explain about Unit 1, which is over voltages in electrical power system. Uh, These are the topics we are going to discuss today on the lecture: causes of over voltages and lightning phenomena, charge formation of lightning, rate of charging of thunderclouds, and mechanism of lightning strokes, characteristics of lightning strokes, factors contributing on good line design, protection afforded by ground wires, tower footing resistance, interaction between lightning and power system, mathematical modeling of lightning. First, we'll discuss about causes of lightning. As you all know, lightning is a natural phenomena. That means a cloud, the charged cloud is discharged to the ground. That means a peak discharge, that the charge accumulated in the cloud is discharged to nearby cloud or ground. This is mainly due to the electrode separation. That means our cloud and ground act as electrodes, which is usually separated at a kilometer range of 10 kilometer or more than. And cloud to cloud distance will be more than 10 kilometers. Next, charge formation of the cloud means the cloud which is separated by positive and negative charges due to high air current, where ice crystals on the upper part and the lower part consist of water parts. Okay, these two parts are separated by heavy air current. The charge depression of the cloud which increases means if charge centers will be formed. Usually it will be range of 2 kilometers. Whenever the charge density is 10 kilovolt per centimeter, then the cloud started to discharge to the ground or nearby cloud. That means the cloud charge inside the cloud will be around 1 to 100 coulombs, and the potential will be 10 power 7 to 10 power 8 volt. And that means, which I have previously said, if the discharges happens only when 10 kilovolt per centimeter is happens, then the energy discharge is 250 kilowatt hours. That much energy will be discharged from the cloud. Next, this is the simple structure of how the cloud is discharges. Cloud is usually made up of both charges, positive and negative. Positive, that means ice crystal will be present in the upper part, and the rain will be present in lower part. These two act as an electrodes where high charge is stored. When there is a charge density happen, that means charge enter is formed, the cloud discharges the accumulated charge to the ground or nearby ground. Okay, this is a simple diagram. Then the mechanism of lightning, that means the lightning directly hits the ground by using of these kind of mechanisms. Like first, stepped leader and pilot steamer will happen, then the ground steamer or return stroke, then subsequent strokes will happen. That means initial part of the cloud starts to discharge the stepped leader is known as stepped leader, then it touches the ground, it will known as return stroke or ground steamer. If multiple strokes happens, it is known as subsequent strokes. See, this is the pilot steamer. That initial, when the cloud charge accumulated is more than 10 kilowatt per centimeter, the charges stored in the cloud started to discharge outside the clouds. That is known as stepped leader. It takes its path towards the ground. Next is when the charge from the cloud touches the ground, it will forms as a ground steamer. Initial is known as stepped leader, then second is known as ground steamer. That means the return current is formed, which cannot move upwards for more than 1 or 2 kilometers. Next is multiple strokes. Multiple strokes, you will have more strokes on the clouds. Then we are going to discuss about the characteristics of lightning stroke. That the characters mainly depends upon the current and the time, and also time to peak or rate of rise, how fast the cloud charges is rising, and the distribution of the current and time, and the wave shape of the lightning voltage and current. That means it will be mostly of impulse waveform. Then the characteristics of lightning strokes depends on these parameters. What is the lightning current? That means short front time. That means in 10 microsecond it reaches its peak value, and tail time will be several milliseconds. Okay, in 10 microsecond it will reach its maximum. Like example, it is 10 power 7 volt means it will reach that much value in 10 microseconds. What is rate of rise? Rate of rise is 10%, 50% increase. That means 50% of lightning stroke is current will be 7.5 kilo amperes per microseconds. Then 10% means 25 kilo amperes per microsecond. When the stroke current is more than 30 milliseconds means or microsecond, it will give to rate of rise. Then about surge voltage. Surge voltage means the transient voltage discharged from the cloud. These are the details that will have a maximum of 5 megavolt and which hits at a line of 1000 kilovolt. The front time will be 2 to 10 microseconds and the tail time will be 20 to 100 microseconds. Then the rate of rise of the voltage will be 1 megavolt per microsecond. These are the details that we'll discuss under surge voltages. Next, we'll move to lightning strokes. There are only two different types of strokes. One is direct and induced stroke. Direct stroke means which directly hits on the transmission line or wire or any tower. Indirect stroke means the cloud generated the charge hits the base of the earth that will induce the current in the nearby objects or any other transmission lines. Next, overvoltage is due to switching transient. The main two causes of overvoltage is first is internal cause, second is external cause. The external cause that is comes under lightning which have we discussed previously. Now we are switching towards internal cause. Internal cause is mainly due to switching surges. Switching surges, we'll see just introduction. In switching surge, then the over voltage that generated due to the switching operation that will be a long duration. In lightning it will be short duration, in switching it will be long duration. Then the switching over voltage depends mainly on the normal operating voltage of the system. If I'm operating a switch which is working on a 11 kV system, then the surge voltage depends upon that 11 kV. Next, the origin of switching surge. As we said, the making and breaking of the electric circuits or switch gears or circuit breakers which will lead to an abnormal voltage or transient voltage. Due to its these are the internal causes. Then over voltage will be more than, that means it will be 6 times the normal power frequency voltage. If a system is operating under 11 kV, then the surge voltage may be exceed 66 kV. Then circuit breakers are the main causes for the switching surges because when we are breaking the switch, it will create arch. That arch will lead to an over voltages. And also switching surges which include natural frequencies of system, damped normal frequency voltages, and the restrikes and recovery voltage and the successive reflected waves. These are the parameters we want to consider when discussing about the origin of switching surges. Next, these are the characteristics of switching surges. First, the thing is depends on the transmission line, cable, shunt capacitance, and the bank's de-energization. When we are de-energizing a capacitor or a capacitor banks, it will lead to switching surge. Or disconnecting a unloaded transformer, or energizing or reclosing of a reactive loads, or sudden switching of the loads, or short circuit faults and fault clearance, resonance, ferroresonance, and arching grounds. These are the main causes of switching surges. Then how to control the over voltages due to switching? These are the points comes under this. That means the phase controlled close of a circuit breaker which will reduce the over voltages. Then the drainage of the trapped charges before the reclosing. That means we want to drain out the charges before reclosing, or using shunt reactor to compensate the capacitor effect, or limiting the switching surges by switching dividers. We want to use dividers to reduce the current value, or energization of transmission line in one or more steps by inserting resistors. By inserting resistance, we will reduce the current. Automatically, it will lead to reduction of over voltages. These are the points which comes under the control of over voltage due to switching. Next, protection. We have discussed detailedly about two causes, internal and external cause. External cause we cannot do anything with natural parameters, but internal cause we'll do with protection. The main protection of over voltages which comes under the minimizing the lightning over voltage by suitable line design. We want to design a arresters and ground wires and guards and surge dividers in order to protect the system against over voltages. First, we want to use the proper shielding of overhead lines, that will use a ground wire, and we will use ground rods and counterpose wires, and including the protecting devices like explosive gaps, protected tubes and surge dividers in substation and line terminals. It will comes under the protection of over voltages. Next, the overall protection of the system will depends upon the system design. Okay. In this topic, we have detailedly discussed about what are the causes of over voltage and how we will protect the system under the over voltages. Thank you for your patience listening. Thank you all.